Good morning, everyone. First, I would like to say I'm very honored to be in this special city, Beirut. It's really a very special city, at least to me. And I would like to take this opportunity to say congratulations to FISUEL Committee on this wonderful, actually astonishing arrangement that discuss a critical topic to human safety and to future sustainability, which is renewable energy. From Dubai, I did watch the diverse presentation from Tuesday program. It's a job well done, and like they say, hats off for the committee. Thank you for this event. Now, my name is Mohamad Nassereddine. I'm from the American University in Dubai School of Engineering. Today, I will be talking to you briefly about lighting design for photovoltaic solar farm. During the presentations, we give a quick introduction about lighting design for PV farm, lighting shield, lighting performance, lighting design layout and products, lighting design and recommendations. Now, before we start, what's a lighting? There's many theories behind lighting phenomena. For me, I prefer IEEE standard. IEEE standard states that attribute charge separation to the existence of both positive and negative ions and the existence of a normal electric field directed toward the earth. That's what basically causes the lightning strike. What's a lightning strike? Lightning strike, you have multiple types of stroke or strike. You have strike between or within the cloud, strike between two different clouds, strike to a surrounding structure, and strike to the ground. The positive and negative stroke terminates on the ground are the type of the most interest in designing lighting shield. There is two elements when designing lighting shield. There is the stepped leaders, which is due to the ionization of the air surrounding the lighting, and has a magnitude around 100 amps. So that's a very low and you can't control it. The biggest problem is the return stroke. The return stroke is the one that has the bright streamer that propagate upward from the earth to the cloud. This has an average current weight of 24,000 amp. This figure shows you the stepper leaders and the streamers. And you can see the main discharge, the one of interest to us. In this paper, or this presentation, we divided the lighting design into two sections. Lighting shield. The lighting shield is the first defense against lightning strike. And then we talk about lighting performance. As you will see throughout the presentation, lighting shield is not sufficient on its own to give you comfort when it comes to lighting design. Lighting performance is you want to assess your electric installed apparatus or protection devices to make sure that it's compliant to standard. What's a lighting shield? Lighting shield, there's a two type of lighting shield design. One of them based on an angle, one of them based called rolling sphere method. IEEE 998 uses rolling sphere method, and there is some other standard like Australian New Zealand standard 1768, they use the angle. Both have similar, actually you can say 98% identical approach. Now, what's a lighting shield? What's a rolling sphere lighting shield? The idea behind the design is to establish a structure that if you have a lightning strike with a distance strike of S, which is form a sphere of radius S, if you roll the sphere, the protected items will not be touched, will not be exposed to a lightning sphere. As you can see from this figure, you will have this equipment on your right hand side. It's not protected because it has a probability, a percentage for intercept a lightning. For us to design a lightning strike, it's very important now to determine the lightning current magnitude and the distance, the strike distance, and of course, you need the object details. We need the object details. Now, how to determine the lightning strike distance? There is 4 main equations that worldwide standard use. These are the 4 main equations. S represent the strike distance. I represent the magnitude of the lightning strike. Many countries, this is by the way, IEC and IEEE uses this equation. There's many other countries like Australia and New Zealand, they created their own standard, and what they've done is they introduced a table based on the level of protection, and the level of protection will depend on many factors, such as the criticality of your design, of your infrastructure, the interception current, and then they will determine the radius of the sphere. Any approach you will follow, at the end, you will have to design the mast. In order for us to design the mast, there is a multiple option to design the mast. Number one is, I need to design a mast, as you saw from the rolling sphere method. I need to know the detail of my structure. I need to understand, where can I place the mast? Maybe I can place it on top of it. Maybe I have some restriction. I have to place it 5 meters away from it. So this is an example. If I have a structure of a height D, I'm forced to put a mast at a T distance from it. If I have a strike of an A, lightning strike of an A, if I do some calculation, I end up having this relationship for the height. If I want to protect the same object using two lightning masts, same object, I place two lightning masts. Now, the separation of the two lightning masts is distance m. By using some analysis, I end up having this relationship. Whenever you do any design, one lightning mast required a very tall. And when it comes now to lightning assessment performance, you will see what will happen to the height. When you have a higher structure, you have a higher risk. Now, it's all known. It's evidence that lightning energy can cause catastrophic damage. This catastrophic damage, not only to solar, to any other infrastructure, worldwide, it's agreed for all companies. When you go to utilities, you go to investors, it's unacceptable to rely only on the lightning shield as a measure of defense. What we have to do now, we have to assess if the lightning shield failed. We need to do lightning performance assessment. In order for us to do lightning performance assessment, you need to obtain numerous data, which are the ground flash density. This data is being recorded for every country. The average annual coronic level, TD. And for your information, based on the IEEE standard, ground flash density is equal to 12% of TD. You need to understand, after you determine this, you need to get the number of strike for the proposed mast. NG represents the ground flash density. SG is the separation between mast. So if you have two masts, if you have one mast, this answer will be 0. And you will have the height, H of the mast that you propose. The final element that you need to do when it comes to lightning performance assessment is you need to make sure that your nominated voltage, whenever you design a system, you have an insulation level. You have an insulation level. You need to make sure that the insulation levels comply with the surge voltage. What's the surge voltage for lightning? When a lightning hit the ground, that's the most important element for us. When a lightning hit the ground, it will create a surge voltage because you have a current and you have a surge impedance. Surge impedance with the current causes the surge voltage. Therefore, Earthgrid play an important role because based on my Earthgrid resistance, my surge voltage will be determined. And based on my surge voltage will be determined, we'll see, is it comply with my insulation level that has been designed? The Earthgrid can be made by single electrode, multiple electrode, or could be made by combination of a mesh and an electrode. Now, it's very important for us to notice the following two equations. Under low frequency, it's been proven that the resistance of a single electrode is related to the soil resistivity the depth of the electrode and the diameter of the electrode. However, under lightning strike, because of the higher frequency, we no longer have a resistance. Now I have a surge resistance or surge impedance. The surge impedance related to the RP, which is the low frequency resistance of the electrode, divided by the current. This is I, is the magnitude of the lightning strike, and also related to stuff called IG, which is the current limit that initiate sufficient soil ionization. And according to the standard, this is IG. Now, 300 kilovolt per meter, it's a soil ionization grading. So you can see now no longer have normal resistance. And for your information, because of the high frequency, you know the span of the transmission line that was 1 ohm or 0.5 ohm, and the lightning strike, it's a 500 ohm. See the difference? So this is very important for us to determine. Now, after we determine, we obtain all these informations, we need to decide as an engineer on the layer and product. So it's very critical for us to know the soil resistivity, the ground flush density, the insulation level. The reason is, based on this information, we'll make a decision. Do we place the mast touching the structure or no? If you place the mast touching the structure, that means your V insulation must be bigger than the V surge. And the V surge, depending on the lightning strike magnitude and the Earthgrid installed. If your system cannot maintain the V surge, you have to put a separations. And the separation also depend on the flush over, the insulation level that it's required based on a soil resistivity, based on air, depending on your medium. So from a product perspective, what do I need? I need surge arrestor. I need different type of surge arrestor, and I need an insulation medium. Insulation medium could be, you can have a line post, you can have a long rod. It can depend on your separation that you want to insulate. Now, this is ABB product. ABB will show you that for a system to be compliant, you need to have 2 surge arrestors. You need to have one on the DC side, one on the AC side. Under the condition where the shielding angle couldn't protect 100%, and a lightning energy manages to reach the wires, the first surge arrestor will make sure that the lightning energy is being discharged to the ground and doesn't allow it to go to the inverter, to the DC-AC inverter. Under circumstances where the lightning energy reaches the AC side, under any circumstances, the second surge arrestor will make sure that it will discharge this energy and stop it from reaching the AC grid and the grid for your house, because it's going to cause severe damage. The main product that you need for the lightning design, you need the lightning head, you need the lightning mast, you need, it's very important, guys, very, very important to have a fuse for lightning. This is not the fuse for your power distribution. That's a fuse for the lightning to protect the lightning surge arrestor. And what they've done in a major PV farm, we need to install, there's a remote signaling. This remote signaling will tell us how many times we'll trip, and will tell us all these details. It's very important because remember, renewable energy, it's a developed technology. It's, we're going to install, I'm hoping that in Lebanon we'll install in hundreds of megawatt capacity. We don't know this data. By installing this device, just to take the system, that will give us a great advantages for a future development. Now, to conclude what we discussed, it's very important to ensure adequate design by data gathering. Soil resistivity, it's one of the main elements. Without soil resistivity, you cannot do the design. You need the current Earthgrid layout. Why do I need the current Earthgrid layout? Because I need to see, should I connect to the same Earthgrid or separate Earthgrid? Soil infrastructure details. I need to see, what am I protecting? Am I protecting one on top of the house? Am I protecting one element with axis tracking? Or am I protecting a solar farm? The height and the width of it. the installed apparatus surge impedance level. So I have already existing system, or I have the design. Someone, as the lining designer, will provide me with a single line diagram with the electric design. I need to know all this information. The installed installation level, ground flash density, and finally the coronig level. Now, after I obtain all this data, the first I proceed with the mast design. My recommendation is install the mast away from your PV solar farm if possible. If possible, install separate earthing system, because if you have any doubt regarding your surge impedance or your surge voltage, if you separate the two earths together with an adequate separation distance, you will eliminate or you reduce the risk of a flashover. Determine the number of masts and height using the rolling sphere method. And at the end, we do lightning performance. Compute the surge impedance, compute the surge voltage, verify that the current installed installation and surging level meet the V surge due to a lightning strike. And at the end, you proceed with the design report. Thank you.